everybody, I'm Gandhimati from Muttayamal Engineering College. Today I'm going to take a topic RAID. The expansion for RAID is redundant array of independent disk or inexpensive disk. The RAID is used to store multiple data in multiple disks. Therefore, the benefits of RAIDs are it uses multiple disks and it store mass or huge amount of data. It is duplicate data in every disk. By the duplication, it provides fault tolerance. Fault tolerance means if any disk fails, we can get data from other disk. By that, it improve overall performance, and due to multiple disks it increase storage capacity in a system, and also the RAID allowed to store same data redundantly, that is in multiple places. RAID disk drive are used frequently on server and it is not used in a personal computer. There are many levels of RAID where it use 6 level, and the RAID is used in different architecture and it depend on performance and fault tolerance. The RAID level describe how data is distributed across the drives. Already I have told that it have 6 level. In that, the first level name is striped disk array. It provides data striping, that is spreading out block of each file across multiple disk drive. As shown in diagram, the data is scattered in one another disk. Here, no duplication is provided, that is no redundancy is provided. It improve a performance but not fault tolerance, because if one drive fail, then all data in that array is lost and we cannot get that data again. It is failed level, that it is not used now. Next level is mirroring and duplexing, that is it provide disk mirroring, that is duplicate writes of data is provided in level 1. It provides twice the read transaction rate of single disk. It also improve performance and also fault tolerance, because if one disk fails, we can get data in other disk. The next level is level 0 plus 1. It use both mirrored and striping value as shown in a diagram. So it provides both the benefits of level 0 and level 1 RAID disk. And here the advantages, it the high data transfer performance performed in level 0 plus 1. The next level is level 2, that is bit level striping with dedicated Hamming code parity or error correction code. Here the data is striped over all the disk, and here the error code for each disk is given, which is used to correct, or it is used to verify the data is correct or not by using single bit, which is called as error code bit. It is extremely used to transfer high data rate, and also it consists of ECC error correction code. Maximum it use Hamming code technique to detect and correct the errors. The next level is level 3. The name was byte interleaved parity, which provide byte level striping with dedicated parity bit. Here for each stripe, for example, consider A is a stripe. For that, one parity bit is placed in this disk, and all the parity bit is placed in separate disk in the RAID. Here, parallel transfer with parity on a data block is striped, and the data will be written in the disk. And next level is level 4, block interleaved parity. Independent data disk with shared parity disk was used. Here, parity bit check error is placed in each disk block. Nowadays, commonly used level is level 4, and level 4 provide block level striping like level 0, but it have extra bit called parity bit in each disk. If a data disk fails, the parity data is used to create a replacement disk. And the advantage of level 4 is that the parity disk can create bottleneck problem. Example, it shown in a diagram where for each block a parity bit is used, and all the parity bit is used in separate array of disk. The next level is level 5, where it can be called as block interleaved distributed parity. Instead of placing a parity bit in separate array of a disk, the parity bit is placed in each array of disk here. Entire data block is written on a data disk along with a parity bit also generated on that disk. It provides data striping at the byte level and also stripe error correction information. This results in excellent performance and good fault tolerance. Level 5 is one of the most popular implementation of RAID level. As shown in a diagram, in each disk, it consists of a parity bit. The last level is level 6, which we can call as P plus Q redundancy. That is, instead of single bit parity bit in an array of disk, it consists of two parity bit, where independent data disk with double parity is used to protect against multiple disk, and also it provides block level striping with parity data distributed across all the disk. By this, all the levels of RAID was over. Thank you.